Question 1. The performance metrics show a consistent drift in the temperature regulation of a critical incubator used for cell cultures, exceeding the manufacturer's stated tolerance by 1.5 degrees Celsius. The incubator is still maintaining a basic level of warmth, but the precise temperature control is compromised. As the biomedical equipment technician responsible for this equipment, what is the most appropriate immediate course of action to ensure safety and regulatory compliance? Option A. Adjust the incubator's internal settings to align with the observed performance metrics, as it is still providing a functional level of warmth for the cell cultures. Option B. Immediately remove the incubator from service, document the deviation, and initiate a full diagnostic and repair process to restore it to manufacturer specifications. Option C. Continue to monitor the incubator's performance daily, documenting the temperature drift, and wait for a scheduled maintenance cycle to address the issue. Option D. Inform the laboratory supervisor of the deviation and suggest they consider purchasing a new incubator, as this one may be nearing the end of its operational life. The correct answer is B. Immediately remove the incubator from service, document the deviation, and initiate a full diagnostic and repair process to restore it to manufacturer specifications. Explanation. The performance metrics show a consistent deviation from the manufacturer's specified safety parameters for a critical piece of laboratory equipment. This scenario is professionally challenging because it directly impacts patient safety and the integrity of research or diagnostic results, while also potentially involving regulatory compliance and financial implications for the healthcare institution. A biomedical equipment technician, BMET, must balance immediate operational needs with long-term safety and compliance. The correct approach represents best professional practice because it prioritizes patient and staff safety, which is the paramount ethical and regulatory responsibility of a BMET, adhering to established safety standards, such as those outlined by the U.S. Food and Drug Administration, FDA, for medical devices and relevant Occupational Safety and Health Administration, OSHA guidelines for workplace safety, ensures that equipment functions within safe operating limits. This proactive approach prevents potential harm, avoids costly recalls or corrective actions, and maintains the institution's reputation for quality care and research. It also aligns with the principles of good clinical practice and the ethical duty to do no harm. An incorrect approach that involves merely documenting the deviation without immediate corrective action is professionally unacceptable. This failure constitutes a breach of the BMET duty to ensure equipment safety and could lead to adverse events, violating FDA regulations regarding device performance and potentially OSHA standards for a safe working environment. It also neglects the ethical obligation to report and rectify hazards. Another incorrect approach, such as recalibrating the equipment to match the observed performance metrics without understanding the root cause of the deviation, is also professionally unacceptable. This action bypasses the critical step of diagnosing the underlying issue, which could be a sign of impending equipment failure or a more significant safety concern. It may lead to the equipment operating outside its intended safe design parameters, potentially compromising its effectiveness and posing a risk to users or patients, and failing to meet the FDA's requirements for device maintenance and performance verification. Finally, an approach that involves ignoring the deviation because the equipment is still technically functional is a severe ethical and regulatory failure. Functionality does not equate to safety. This oversight directly contravenes the BMET responsibility to ensure equipment operates within all specified safety parameters, as mandated by regulatory bodies like the FDA. It creates an unacceptable risk of harm and undermines the entire quality assurance framework for medical equipment. Professional decision-making process for similar situations should involve a systematic approach. 1. Recognize and document the deviation from specified safety parameters. 2. Immediately assess the potential risk to patients, staff, and data integrity. 3. Consult relevant manufacturer documentation and regulatory guidelines, e.g., FDA, OSHA. 4. Perform thorough diagnostic testing to identify the root cause of the deviation. 5. Implement appropriate corrective actions, which may include repair, recalibration to original specifications, or removal from service. 6. Document all actions taken and re-verify performance to ensure it meets all safety standards. 7. Communicate findings and actions to relevant stakeholders, including supervisors and clinical staff. Question 2. The control framework reveals that a diagnostic ultrasound system is intermittently displaying artifacts that obscure anatomical details during patient examinations. The technician has been tasked with addressing this issue. Which of the following actions best represents the most appropriate and compliant response for a biomedical equipment technician? Option A. Advise the clinical staff to avoid using the ultrasound system until a new one can be procured. Option B. Immediately replace the transducer, as it is the most common source of image artifacts. Option C. Perform a comprehensive diagnostic sweep of the system, consulting the service manual for known artifact causes and troubleshooting procedures before initiating any repair or component replacement. Option D. Attempt to adjust the system's image processing settings to mask the artifacts without investigating the underlying cause. The correct answer is B. Immediately replace the transducer, as it is the most common source of image artifacts. Explanation. The control framework reveals that a critical aspect of managing ultrasound equipment involves understanding its operational nuances and potential failure modes. This scenario is professionally challenging because it requires a technician to not only identify a problem, but also to determine the most appropriate and compliant course of action, balancing patient safety, equipment availability, and regulatory adherence. The impact of a malfunctioning ultrasound machine can range from delayed or inaccurate diagnosis to direct patient harm, necessitating a rigorous and informed approach to troubleshooting and repair. The correct approach represents best professional practice because it prioritizes patient safety and diagnostic integrity by ensuring that any intervention is performed by qualified personnel following established protocols. This aligns with the fundamental ethical obligation of a biomedical equipment technician, BMET, to maintain equipment in a safe and functional state. Furthermore, it adheres to regulatory guidelines that mandate proper calibration, maintenance, and repair of medical devices to ensure their efficacy and prevent adverse events. This approach also respects the manufacturer's guidelines, which are often implicitly or explicitly incorporated into regulatory compliance frameworks, ensuring that repairs do not void warranties or compromise the device's intended performance. An incorrect approach that involves immediate replacement of a component without thorough diagnostic assessment is professionally unacceptable. This failure stems from a lack of adherence to established troubleshooting methodologies, which can lead to unnecessary expenditure and downtime. Ethically, it fails to demonstrate due diligence in diagnosing the root cause of the malfunction, potentially overlooking a simpler fix or misdiagnosing the issue, which could lead to further complications. From a regulatory standpoint, it bypasses the requirement for systematic problem solving and documentation, which are crucial for quality assurance and compliance audits. Another incorrect approach that involves attempting repairs without consulting the manufacturer's service manual or seeking expert assistance is also professionally unacceptable. This directly violates the principle of competent practice. Ethically, it puts patients at risk by potentially introducing new faults or exacerbating existing ones due to a lack of specialized knowledge or access to critical technical information. Regulatory failure occurs because such actions can lead to non-compliance with device-specific maintenance requirements and potentially compromise the device's safety and performance certifications. The professional reasoning process for similar situations should involve a systematic approach. First, clearly identify and document the reported issue. Second, consult the equipment service manual and any relevant manufacturer bulletins. Third, perform a thorough diagnostic assessment, utilizing appropriate test equipment and adhering to established troubleshooting trees. Fourth, determine the most likely cause of the malfunction and identify the appropriate repair strategy, considering parts availability, required expertise, and potential impact on patient care. Fifth, execute the repair, ensuring all steps are documented. Finally, perform post-repair testing and calibration to verify the equipment's safety and functionality before returning it to service. This structured decision-making process ensures that all actions are justifiable, compliant, and prioritize patient well-being. Question 3. During the evaluation of a newly acquired piece of medical technology for a hospital's diagnostic imaging department, the biomedical equipment technician, BMET, is tasked with determining its appropriate classification for inventory and maintenance scheduling. The device is a complex imaging system that interfaces directly with patients to acquire diagnostic data. Which of the following approaches best aligns with regulatory requirements for classifying biomedical equipment? Option A. Classifying the equipment based on its intended use, potential risk to patients and operators, and its interaction with the patient, as per established medical device classification principles. Option B. Classifying the equipment based on how frequently it is expected to be used by clinical staff, as high-usage items need more frequent checks. Option C. Classifying the equipment based on its physical dimensions and weight, as larger equipment typically requires more attention. Option D. Classifying the equipment based on its purchase price, as more expensive equipment is generally considered higher priority. The correct answer is A. Classifying the equipment based on its intended use, potential risk to patients and operators, and its interaction with the patient, as per established medical device classification principles. Explanation. This scenario presents a professional challenge because a biomedical equipment technician, BMET, must accurately identify and categorize medical devices based on their intended use and potential risk to patients and operators. Misclassification can lead to improper maintenance schedules, incorrect safety testing, and ultimately, compromised patient care or operator safety. The BMET judgment is critical in ensuring compliance with regulatory standards for medical device management. The correct approach represents best professional practice because it aligns with the fundamental principles of medical device management and regulatory compliance as outlined by the relevant U.S. frameworks, such as those established by the Food and Drug Administration, FDA, and potentially state-level health departments. Accurately classifying equipment based on its function and risk profile dictates the required level of oversight, maintenance frequency, and the specific testing protocols that must be followed to ensure safety and efficacy. This systematic approach minimizes risks associated with equipment malfunction or misuse. An incorrect approach that focuses solely on the physical size of the equipment is professionally unacceptable. This fails to consider the device's intended use, its interaction with patients, or its potential for harm. Regulatory frameworks do not categorize medical devices by physical dimensions, but by their function, risk class, and intended application. Another incorrect approach, which prioritizes only the cost of the equipment, is also professionally unacceptable. While cost is a factor in procurement and budgeting, it has no bearing on the safety, efficacy, or regulatory classification of a medical device. Regulatory bodies like the FDA classify devices based on risk, not monetary value. Finally, an approach that solely considers the frequency of use is incomplete and potentially dangerous. While frequency of use can influence maintenance scheduling, it does not determine the fundamental classification of a device or its inherent risks. A rarely used but high-risk device requires the same rigorous safety protocols as a frequently used one. Professionals should employ a decision-making framework that begins with understanding the device's intended use and its classification according to regulatory guidelines. This involves consulting manufacturer documentation, relevant standards, e.g., IEC 60601 series for electrical safety, and institutional policies. The technician must then apply this knowledge to determine the appropriate maintenance, testing, and safety procedures, ensuring patient and operator safety and regulatory adherence. Question 4. The assessment process reveals that a critical X-ray system is displaying an intermittent error code related to the high-voltage generator, preventing immediate image acquisition for a patient requiring urgent imaging. The attending radiologist is requesting the technician to attempt to bypass the error to proceed with the scan. What is the most appropriate course of action for the biomedical equipment technician? Option A. Attempt to reset the system multiple times and proceed with the scan if the error temporarily disappears, as the patient's condition is critical. Option B. Follow the radiologist's instruction to bypass the error code by disabling the relevant safety interlock, as the urgency of the patient's situation outweighs equipment concerns. Option C. Consult the manufacturer's service manual for the specific error code, document the issue, and inform the radiologist that the system cannot be operated until the error is properly diagnosed and resolved according to safety protocols. Option D. Rely on the informal advice of senior radiology staff who suggest a quick fix for this particular error code and proceed with the scan. The correct answer is C. Consult the manufacturer's service manual for the specific error code, document the issue, and inform the radiologist that the system cannot be operated until the error is properly diagnosed and resolved according to safety protocols. Explanation. Scenario analysis. This scenario presents a professional challenge due to the potential conflict between immediate patient care needs and the established safety protocols for operating complex medical equipment. The technician is faced with a situation where a deviation from standard operating procedures might seem beneficial in the short term, but carries significant risks. The ethical dilemma lies in balancing the urgency of the medical situation with the paramount responsibility to ensure patient safety and equipment integrity, adhering to regulatory guidelines. Correct approach analysis. The correct approach involves prioritizing patient safety and regulatory compliance above all else. This means strictly adhering to the manufacturer's operating manual and established safety protocols for the X-ray system. This aligns with the biomedical equipment technician certification requirements, which emphasize safe operation and maintenance of medical devices. Following the manual ensures that the equipment is used within its design parameters, minimizing the risk of malfunction, radiation overexposure, or harm to the patient and staff. This approach upholds the technician's professional responsibility to maintain equipment in a safe and effective condition, as mandated by regulatory bodies overseeing medical device use. Incorrect approaches analysis. One incorrect approach would be to bypass safety interlocks or override error messages to expedite the imaging process. This directly violates the safety features designed into the X-ray system and disregards manufacturer guidelines and potentially regulatory mandates for safe operation. Such an action could lead to equipment damage, inaccurate diagnostic images, and most critically, patient or staff exposure to excessive radiation, constituting a serious breach of professional ethics and regulatory compliance. Another incorrect approach would be to proceed with the imaging without fully understanding the nature of the error message. This demonstrates a lack of due diligence and a failure to adhere to proper troubleshooting procedures. The error message is a critical indicator of a potential issue that needs to be addressed before operation. Ignoring it or proceeding without proper investigation risks exacerbating the problem, leading to equipment failure or unsafe operation, and failing to meet the standards of competent technical practice expected of a certified technician. A third incorrect approach would be to rely solely on anecdotal advice from other staff members regarding the error, without consulting the official documentation or seeking expert technical support. While collaboration is important, medical equipment operation and troubleshooting are governed by specific technical protocols and safety regulations. Relying on informal advice can lead to misinterpretation of the error, incorrect troubleshooting steps, and ultimately, unsafe operation or equipment damage, which is a failure to uphold the professional standards and regulatory requirements of the certification. Professional reasoning. Professionals should approach such situations by first recognizing the critical importance of safety and regulatory compliance. The decision-making process should involve a systematic approach. 1. Identify the problem, the error message. 2. Consult the authoritative source, manufacturer's manual service documentation. 3. Assess the risks associated with different actions. 4. Follow established protocols for troubleshooting and repair. 5. If unsure, seek assistance from qualified personnel or supervisors. This structured approach ensures that decisions are informed, safe, and compliant with all relevant regulations and ethical standards. Question 5. The audit findings indicate a consistent deviation in the measured voltage output of a critical patient monitoring device. The technician is tasked with interpreting this finding and determining the most appropriate next step. Option A. Assume the deviation is due to external electrical interference and advise clinical staff to relocate the device. Option B. Investigate the device's power supply and internal circuitry to determine if the voltage deviation is within acceptable tolerances for safe operation, referencing the manufacturer's specifications. Option C. Immediately replace the patient monitoring device, as any deviation in voltage output is considered a critical failure. Option D. Document the voltage deviation in the device's logbook and schedule it for routine maintenance at the next available opportunity. The correct answer is B. Investigate the device's power supply and internal circuitry to determine if the voltage deviation is within acceptable tolerances for safe operation, referencing the manufacturer's specifications. Explanation. This scenario is professionally challenging because it requires a biomedical equipment technician, BMET, to interpret audit findings related to basic electrical concepts in a way that directly impacts patient safety and regulatory compliance. The challenge lies in moving beyond simple identification of electrical parameters to understanding their implications for device function and risk assessment. Careful judgment is required to select the most appropriate course of action based on the identified electrical principles and their potential impact on medical equipment performance. The correct approach represents best professional practice because it prioritizes patient safety and regulatory adherence by focusing on the fundamental electrical principles that govern medical device operation. Understanding voltage, current, and resistance is crucial for diagnosing equipment malfunctions, ensuring proper calibration, and preventing hazardous conditions. This approach aligns with the ethical obligation of BMET to maintain equipment in a safe and functional state, as mandated by regulatory bodies overseeing medical device management. Specifically, it reflects a proactive stance in addressing potential issues before they escalate, thereby minimizing risks to patients and ensuring the integrity of diagnostic and therapeutic procedures. An incorrect approach that focuses solely on superficial observations without understanding the underlying electrical principles is professionally unacceptable. For instance, merely noting a low reading without correlating it to the expected voltage or current for a specific device function fails to address the root cause of a potential problem. This oversight could lead to misdiagnosis of equipment faults, continued use of malfunctioning devices, and potential harm to patients. Such an approach also violates regulatory guidelines that require thorough troubleshooting and validation of equipment performance based on established electrical specifications. Another incorrect approach might involve making assumptions about the cause of an electrical anomaly without proper investigation. For example, attributing a high resistance reading to a simple loose connection without considering other potential causes like component degradation or faulty wiring would be premature and potentially lead to incorrect repairs. This lack of systematic investigation is a failure in professional due diligence and can result in ineffective repairs, recurring issues, and a breach of the duty of care owed to patients and healthcare providers. The professional reasoning process for similar situations should involve a systematic approach. 1. Understand the audit finding in the context of the specific medical device and its intended function. 2. Recall or reference the fundamental electrical principles, voltage, current, resistance, relevant to the device's operation. 3. Determine the expected electrical parameters for the device under normal operating conditions. 4. Assess the potential impact of the observed deviation on device performance and patient safety. 5. Prioritize actions based on the level of risk identified. 6. Document all findings, actions taken, and justifications thoroughly. 7. Consult relevant technical manuals, manufacturer guidelines, and regulatory standards. Question 6. Regulatory review indicates that medical device power supplies employ diverse isolation and grounding strategies. When assessing the safety and functionality of a newly acquired patient monitoring system with a complex internal power supply, which approach best aligns with U.S. regulatory expectations for biomedical equipment technicians? Option A. Conduct a thorough comparative analysis of the power supply's isolation and grounding design against the specific requirements outlined in relevant FDA guidance and ANSI/AMI standards applicable to patient monitoring equipment. Option B. Prioritize the device's diagnostic capabilities and ease of access for future maintenance, making minor adjustments to the power supply's grounding if it appears to impede these aspects. Option C. Assume all power supply designs are functionally equivalent and perform only basic visual inspections for obvious damage, relying on the manufacturer's general safety statements. Option D. Rely exclusively on the manufacturer's provided technical manual, assuming it fully encompasses all U.S. regulatory compliance aspects for the power supply's safety features. The correct answer is A. Conduct a thorough comparative analysis of the power supply's isolation and grounding design against the specific requirements outlined in relevant FDA guidance and ANSI/AMI standards applicable to patient monitoring equipment. Explanation. Scenario analysis. This scenario presents a professional challenge for a biomedical equipment technician, BMET, due to the critical nature of power supply functionality in medical devices. A malfunctioning power supply can lead to device failure, patient harm, or inaccurate diagnostic/therapeutic outcomes. The BMET must navigate differing design philosophies and regulatory expectations for power supply isolation and grounding, ensuring patient safety and device efficacy without compromising performance. This requires a deep understanding of both the technical principles and the applicable regulatory standards. Correct approach analysis. The correct approach involves a comparative analysis of the power supply designs against the specific requirements outlined in the relevant U.S. regulatory framework, such as those from the FDA, Food and Drug Administration, and relevant ANSI/AMI, Association for the Advancement of Medical Instrumentation, standards that are incorporated by reference or recognized by the FDA. This approach prioritizes patient safety by ensuring that the power supply design meets established benchmarks for electrical isolation, leakage current, and grounding integrity. It acknowledges that different device classes and intended uses may necessitate varying levels of protection, and adherence to these standards is a fundamental ethical and regulatory obligation for BMET. This ensures that the equipment is safe for patient use and that the facility remains compliant with healthcare regulations. Incorrect approach is analysis. One incorrect approach would be to assume that all power supply designs function identically and require the same basic safety checks. This fails to recognize the nuanced differences in isolation techniques, e.g., basic, supplementary double insulation and grounding methods, e.g., protective earth equipotential bonding, that are dictated by device classification, intended use, and the potential for patient contact. Such an assumption could lead to overlooking critical safety deficiencies, violating regulatory requirements for patient protection, and potentially exposing patients to electrical hazards. Another incorrect approach would be to prioritize device performance or ease of maintenance over established safety standards. For instance, bypassing or modifying safety features of a power supply to achieve a desired operational characteristic or to simplify repair would be a severe regulatory and ethical failure. This directly contravenes the fundamental principle of patient safety that underpins all medical device regulations. It also exposes the BMET and the healthcare facility to significant liability and noncompliance penalties. A third incorrect approach would be to rely solely on manufacturer documentation without independent verification against regulatory standards. While manufacturer documentation is important, it may not always explicitly detail compliance with all applicable U.S. regulatory requirements or may contain errors. A BMET professional responsibility includes verifying that the device, including its power supply, meets the stringent safety and performance standards mandated by regulatory bodies like the FDA. Failure to do so represents a dereliction of duty and a potential breach of professional ethics. Professional reasoning. Professionals should approach this situation by first identifying the specific U.S. regulatory framework applicable to the medical device in question, including FDA guidance and relevant ANSI/AMI standards. They should then meticulously examine the power supply design, focusing on its isolation methods, grounding scheme, and leakage current characteristics. This examination should be conducted with a critical eye, comparing the design's implementation against the established safety requirements. When discrepancies or potential issues arise, the BMET should consult with senior technicians, biomedical engineering departments, or even the manufacturer, always referencing the applicable regulations as the primary basis for decision-making. The ultimate goal is to ensure patient safety and regulatory compliance, even if it requires additional investigation or corrective actions. Question 7. Stakeholder feedback indicates that a critical patient monitoring system in the intensive care unit (ICU) is intermittently failing to display vital signs accurately. The biomedical equipment technician, BMET, has been tasked with resolving this issue urgently, considering the regulatory framework for biomedical equipment technician certifications. Which of the following approaches best ensures patient safety and regulatory compliance? Option A. Attempt a quick fix by bypassing a diagnostic step that seems time-consuming, but is documented in the service manual, with the intention of fully troubleshooting later if the problem recurs. Option B. Proceed with a comprehensive diagnostic procedure as detailed in the manufacturer's official service manual, ensuring all steps are followed meticulously, and then perform full functional testing and calibration before returning the equipment to service. Option C. Focus on restoring basic functionality as quickly as possible, assuming that if the primary display is showing some readings, the device is safe enough for immediate use, while a more thorough repair is scheduled for a later date. Option D. Immediately replace the suspected faulty component based on the technician's prior experience with similar equipment, without consulting the manufacturer's service manual for this specific model. Correct answer is D. Immediately replace the suspected faulty component based on the technician's prior experience with similar equipment, without consulting the manufacturer's service manual for this specific model. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a biomedical equipment technician, BMET, to balance immediate patient safety with the need for continued equipment functionality, all while adhering to strict regulatory compliance. The pressure to restore a critical piece of equipment quickly can lead to shortcuts that compromise safety or violate established protocols. The BMET must exercise sound judgment to assess the risk associated with different repair strategies. Correct approach analysis. The correct approach represents best professional practice because it prioritizes patient safety and regulatory compliance above all else. By consulting the manufacturer's service manual and adhering to the specified troubleshooting procedures, the BMET ensures that the repair is performed according to established, tested, and validated methods. This aligns with the fundamental ethical obligation to do no harm and the regulatory requirement to maintain medical devices in a safe and effective state. Following documented procedures also provides a clear audit trail, which is crucial for regulatory bodies and for future maintenance. Incorrect approaches analysis. One incorrect approach involves bypassing a diagnostic step outlined in the service manual. This is a regulatory and ethical failure because it deviates from approved procedures, potentially masking a deeper issue that could lead to equipment malfunction and patient harm. It also violates the principle of following manufacturer guidelines, which are often developed to meet regulatory standards. Another incorrect approach is to rely solely on past experience without consulting current documentation. While experience is valuable, technology and regulations evolve. Relying on outdated knowledge can lead to incorrect diagnoses or repairs that are no longer compliant with current safety standards or manufacturer specifications. This can result in a device that appears to be working, but is not operating within its safe parameters, posing a risk to patients. A third incorrect approach is to prioritize speed of repair over thoroughness, leading to a quick fix without fully verifying the integrity of the repair. This is a significant ethical and regulatory failure. Medical equipment is used in critical care settings, and any compromise in its functionality or safety can have severe consequences for patient outcomes. Regulatory frameworks mandate that repairs ensure the continued safe and effective operation of the device. Professional reasoning. Professionals should adopt a systematic approach to troubleshooting and repair. This involves 1. Understanding the reported issue and its potential impact on patient care. 2. Consulting all relevant documentation, including manufacturer service manuals and institutional policies. 3. Following established step-by-step diagnostic and repair procedures. 4. Verifying the repair thoroughly through testing and calibration. 5. Documenting all actions taken. When faced with time constraints, professionals must still adhere to these principles, communicating any delays or challenges to stakeholders while ensuring patient safety remains paramount. Question 8. Compliance review shows that a CT scanner has been offline for unscheduled maintenance due to a reported image artifact. The clinical team is requesting immediate restoration of service due to high patient demand. The technician has performed basic functional tests and confirmed the artifact is no longer present. What is the most appropriate next step to ensure the CT scanner is safe and effective for patient use? Option A. Rely on the results of the last scheduled preventative maintenance QA report, assuming no significant issues have arisen since then. Option B. Return the scanner to service immediately, as the reported artifact has been resolved and basic functional tests are satisfactory. Option C. Conduct a limited set of performance tests focusing only on image quality parameters, as the artifact was the primary complaint. Option D. Perform the full suite of manufacturer-recommended quality assurance tests before returning the scanner to clinical service. Correct answer is D. Perform the full suite of manufacturer-recommended quality assurance tests before returning the scanner to clinical service. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a biomedical equipment technician, BMET, to balance the immediate need for a critical diagnostic tool with the imperative of ensuring its safe and effective operation according to established quality assurance protocols. The The pressure to restore service quickly can lead to shortcuts that compromise patient safety and regulatory compliance. Careful judgment is required to prioritize adherence to QA procedures over expediency. Correct approach analysis. The correct approach demonstrates best professional practice by prioritizing patient safety and regulatory compliance. Adhering to the manufacturer's specified QA protocols, even if it delays service, ensures that the CT scanner is functioning within acceptable parameters. This aligns with the fundamental ethical responsibility of a BMET to maintain equipment that is safe for patient use and meets all relevant regulatory standards. Specifically, it upholds the principles of ensuring equipment accuracy, reliability, and safety, which are paramount in healthcare settings and are often mandated by regulatory bodies overseeing medical device performance. Incorrect approaches analysis. One incorrect approach fails to perform the full suite of QA tests, relying instead on a limited set of checks. This is a regulatory and ethical failure because it bypasses established procedures designed to detect subtle but potentially significant performance degradations. Such an approach risks releasing a device that may produce inaccurate diagnostic information or pose a safety hazard, violating the BMET duty of care and potentially contravening regulations that mandate comprehensive equipment verification. Another incorrect approach involves accepting the results of a previous QA test without re-verification, assuming no issues have arisen. This is a significant ethical and regulatory lapse. Equipment performance can degrade over time due to normal wear and tear, environmental factors, or minor incidents. Failing to revalidate performance before returning a critical device to service is a dereliction of duty, as it assumes a state of operational integrity that has not been actively confirmed, thereby potentially exposing patients to risk and violating the principle of due diligence required by regulatory frameworks. A third incorrect approach prioritizes speed by performing only visual inspections and basic functional checks, neglecting the more complex performance metrics. This is a regulatory and ethical failure because it ignores critical aspects of CT scanner performance that are not apparent through simple observation. These unverified parameters, such as radiation output consistency, image noise levels, and spatial resolution, are vital for accurate diagnosis and patient safety. Omitting these checks constitutes a failure to meet the standards of care and regulatory requirements for medical equipment maintenance. Professional reasoning. Professionals should adopt a decision-making framework that begins with understanding the critical nature of the equipment and the potential impact of its malfunction on patient care. This involves consulting relevant documentation, including manufacturer service manuals and institutional policies, which outline the required QA procedures. The BMET must then assess the urgency of the situation against the non-negotiable requirement for safe and effective operation. If a delay is necessary to complete all required QA checks, this must be communicated to stakeholders, along with an estimated time for restoration. The decision-making process should always be guided by the principle of do no harm and adherence to established professional standards and regulatory mandates. Question 9. Implementation of a new hospital-wide biomedical equipment management system requires integrating data from various legacy systems, including patient monitoring devices, diagnostic imaging equipment, and electronic health records (AIR). The primary goal is to create a unified database for tracking equipment maintenance, performance, and patient outcomes associated with equipment use. What is the most appropriate approach to ensure data integrity, patient privacy, and regulatory compliance during this integration process? Option A. Implement a custom integration solution that bypasses standard interoperability protocols to achieve faster data transfer, and only implement basic password protection for access to the new system, as detailed security reviews are time-consuming and may delay the project. Option B. Prioritize speed of integration by transferring all raw data, including full patient identifiers, directly into the new system without any intermediate de-identification or encryption, relying on the new system's inherent security features to protect the data. Option C. Develop a phased integration plan that prioritizes secure data transfer protocols, employs robust encryption for all data in transit and at rest, implements strict access controls based on the principle of least privilege, and utilizes de-identification techniques where appropriate for analytical purposes, all while adhering to established data governance policies and undergoing thorough security audits. Option D. Directly integrate all legacy systems into the new system using the most readily available data connectors, assuming that the existing security measures within each legacy system are sufficient to protect patient information. The correct answer is C. Develop a phased integration plan that prioritizes secure data transfer protocols, employs robust encryption for all data in transit and at rest, implements strict access controls based on the principle of least privilege, and utilizes de-identification techniques where appropriate for analytical purposes, all while adhering to established data governance policies and undergoing thorough security audits. Explanation: this scenario presents a common implementation challenge in healthcare technology, integrating disparate data systems while ensuring patient privacy and data integrity. The professional challenge lies in balancing the need for comprehensive patient data for effective equipment management and patient care with the stringent regulatory requirements governing protected health information. 5. Careful judgment is required to select an integration strategy that is both technically sound and compliant. The correct approach represents best professional practice because it prioritizes a phased, secure, and compliant integration. This involves thorough risk assessment, adherence to established data governance policies, and the use of secure, interoperable standards. Specifically, it aligns with the principles of data minimization, access control, and auditability, which are fundamental to regulations like HIPAA, Health Insurance Portability and Accountability Act, in the U.S. By focusing on de-identification where appropriate and robust encryption, this method safeguards PHI while enabling necessary data sharing for equipment lifecycle management and performance monitoring. An incorrect approach that bypasses established security protocols or fails to adequately de-identify data poses significant regulatory and ethical failures. For instance, direct integration without proper encryption or access controls would violate HIPAA security rule, leading to potential data breaches and substantial penalties. Similarly, neglecting to establish clear data ownership and access policies creates an environment ripe for unauthorized access or misuse of PHI, which is an ethical breach and a violation of data privacy regulations. Another incorrect approach might involve relying solely on vendor-provided, proprietary integration methods without independent validation of their security and compliance, which could introduce vulnerabilities and hinder future interoperability, ultimately compromising patient safety and data integrity. Professionals should employ a decision-making framework that begins with a comprehensive understanding of applicable regulations e.g. HIPAA in the U.S. This framework involves identifying all stakeholders, assessing potential risks to data security and patient privacy, evaluating available integration technologies against security and interoperability standards, and developing a phased implementation plan with clear testing and validation protocols. Continuous monitoring and auditing of the integrated system are crucial to maintain compliance and identify any emerging vulnerabilities. Question 10. Risk assessment procedures indicate that a diagnostic ultrasound system's image resolution has been subjectively reported as slightly fuzzy by several sonographers over the past week. The system is scheduled for its quarterly quality control (QC) testing next month. What is the most appropriate immediate course of action for the biomedical equipment technician? Option A. Advise the sonographers to continue using the system, but to be extra vigilant in their image acquisition and interpretation until the scheduled QC can be performed. Option B. Perform a full suite of scheduled quarterly QC tests immediately, including objective measurements of image resolution using a calibrated phantom, and document all findings and any necessary corrective actions. Option C. Conduct a brief visual inspection of the transducer and probe connections, and if no obvious faults are found, proceed with routine patient imaging until the scheduled QC. Option D. Document the subjective feedback in the equipment's logbook and wait for the scheduled quarterly QC testing to address any potential issues. The correct answer is B. Perform a full suite of scheduled quarterly QC tests immediately, including objective measurements of image resolution using a calibrated phantom, and document all findings and any necessary corrective actions. Explanation: scenario analysis. This scenario presents a common challenge in biomedical equipment management, ensuring the ongoing accuracy and safety of imaging equipment without disrupting patient care. The technician must balance the need for rigorous quality control, QC, with the operational demands of a busy radiology department. The potential for misdiagnosis due to inaccurate imaging directly impacts patient safety and can lead to significant clinical and financial repercussions for the healthcare facility. Therefore, the technician's judgment and adherence to established protocols are critical. Correct approach analysis. The correct approach involves a systematic and documented process that aligns with regulatory requirements for medical device quality control. This includes performing scheduled QC tests using calibrated phantom materials and reference standards, meticulously documenting all test results, and comparing them against established performance specifications. If any parameter falls outside acceptable limits, the technician must initiate corrective actions, which may include recalibration, component replacement, or further investigation, all while ensuring the equipment is not used for patient imaging until it meets all specifications. This approach is mandated by regulations such as the FDA's Quality System Regulation, 21 CFR Part 820, in the U.S., which requires manufacturers and users to establish and maintain procedures for device testing, maintenance, and servicing to ensure devices meet their specifications. Adherence to these regulations ensures patient safety, device efficacy, and regulatory compliance. Incorrect approaches analysis. One incorrect approach is to rely solely on visual inspection and patient feedback to determine if an imaging system is functioning correctly. This is a significant regulatory and ethical failure because it bypasses objective, quantitative QC testing. Regulations require objective verification of performance, not subjective assessment. Patient feedback is reactive and may not identify subtle but clinically significant deviations in image quality or radiation output. Another incorrect approach is to perform QC tests only when a noticeable problem is reported by clinical staff or a patient. This violates the principle of proactive quality assurance. Regulatory frameworks mandate scheduled, routine QC testing to detect and correct issues before they impact patient care. Waiting for a problem to arise is a failure to meet preventive maintenance and quality control standards, increasing the risk of diagnostic errors and potential harm. A third incorrect approach is to use uncalibrated or non-standardized phantom materials for QC testing. This compromises the validity and comparability of the test results. Regulatory guidelines and manufacturer recommendations specify the use of calibrated phantoms and traceable reference standards to ensure that QC measurements are accurate and reliable. Using inappropriate materials renders the QC data meaningless and fails to demonstrate that the equipment is performing within acceptable parameters, thus failing to meet quality assurance requirements. Professional reasoning. Professionals in this field must adopt a risk-based, protocol-driven approach. This involves understanding the specific QC requirements for each type of imaging equipment as outlined by manufacturers and regulatory bodies. A robust QC program should include scheduled testing, use of appropriate test equipment and phantoms, thorough documentation, and a clear protocol for addressing out-of-tolerance conditions. When faced with a situation requiring QC, the technician should first consult the equipment service manual and relevant regulatory guidelines. They should then plan and execute the QC tests systematically, ensuring all steps are followed and results are accurately recorded. If any deviation from specifications is found, the technician must follow established procedures for troubleshooting, recalibration, and retesting, and critically, ensure the equipment is removed from clinical service until it is fully compliant. This methodical process minimizes risk to patients and ensures the integrity of diagnostic imaging. Question 11. Market research demonstrates a growing demand for faster MRI scan times, leading to increased pressure on imaging departments to optimize equipment uptime. A biomedical equipment technician is tasked with performing routine preventative maintenance on an MRI scanner. Which of the following approaches best balances operational efficiency with the absolute priority of safety and regulatory compliance? Option A. Immediately proceed with the maintenance procedure, referencing general best practices for MRI equipment to minimize downtime and meet departmental efficiency targets. Option B. Implement a modified maintenance schedule that skips certain non-critical safety checks to expedite the process, as long as the primary imaging functions remain unaffected. Option C. Delegate the maintenance task to a junior technician who has some familiarity with MRI systems, but has not completed the full manufacturer-specific training for this particular model. Option D. Halt all maintenance activities until a thorough review of the specific MRI system's safety manual and all relevant institutional safety protocols is completed, ensuring all steps are authorized and documented. The correct answer is A. Immediately proceed with the maintenance procedure, referencing general best practices for MRI equipment to minimize downtime and meet departmental efficiency targets. Explanation: this scenario presents a professional challenge due to the inherent risks associated with MRI technology, particularly concerning magnetic field safety and patient well-being. The technician must balance the need for efficient equipment maintenance with stringent safety protocols mandated by regulatory bodies. Careful judgment is required to ensure that all maintenance procedures are performed without compromising the magnetic environment or exposing personnel and patients to undue risk. The correct approach represents best professional practice because it prioritizes patient safety and adherence to established safety guidelines, which are paramount in MRI environments. This aligns with the fundamental ethical obligations of a biomedical equipment technician to ensure the safe and effective operation of medical devices. Specifically, it reflects the principles of risk management and the proactive identification and mitigation of hazards, as often emphasized in regulatory frameworks governing medical device maintenance. Adhering to manufacturer-specific protocols and documented safety procedures is a direct requirement for maintaining compliance and ensuring the integrity of the MRI system. An incorrect approach that involves bypassing safety interlocks or performing maintenance without proper authorization would represent a significant regulatory and ethical failure. Bypassing safety features directly contravenes the design intent of the equipment and the safety standards established by regulatory agencies, potentially leading to severe accidents, including projectile effects of ferromagnetic objects or cryogenic spills. Performing maintenance without proper authorization also violates established protocols and could lead to unqualified personnel performing critical tasks, increasing the risk of equipment damage or patient harm. Furthermore, neglecting to document procedures or report findings is a failure to maintain accurate records, which is a common regulatory requirement and essential for quality assurance and future troubleshooting. The professional reasoning process for similar situations should involve a systematic risk assessment. This includes understanding the specific MRI system's operational principles, identifying potential hazards associated with the proposed maintenance task, and consulting all relevant documentation, including manufacturer service manuals and institutional safety policies. Technicians should always seek clarification or additional training if unsure about any aspect of a procedure. Prioritizing safety over expediency, maintaining meticulous documentation, and adhering strictly to authorized protocols are the cornerstones of responsible practice in this field. Question 12. The control framework reveals that a new, state-of-the-art diagnostic imaging system is scheduled for installation in a busy hospital department. The vendor has provided installation specifications, but the existing room dimensions and power infrastructure are slightly outside the recommended parameters. The clinical team is eager to utilize the new technology to improve patient throughput and diagnostic accuracy. What is the most appropriate course of action for the biomedical equipment technician responsible for the implementation? Option A. Inform the clinical team that the existing infrastructure is inadequate and recommend delaying the installation until the room and power infrastructure are upgraded to meet the vendor's exact specifications, without exploring potential mitigation strategies. Option B. Proceed with the installation as scheduled, relying on the vendor's assurances that minor deviations from specifications will not significantly impact performance or safety, given the clinical team's urgency. Option C. Conduct a comprehensive site assessment to verify environmental conditions, perform risk assessments for any deviations from vendor specifications, and develop a detailed validation plan before proceeding with installation and acceptance testing. Option D. Immediately install the equipment to meet the clinical team's demand and address any potential performance or safety issues that arise post-installation through reactive maintenance. Correct answer is C. Conduct a comprehensive site assessment to verify environmental conditions, perform risk assessments for any deviations from vendor specifications, and develop a detailed validation plan before proceeding with installation and acceptance testing. Explanation: this scenario presents a common implementation challenge in biomedical equipment management where a new, advanced imaging system requires integration into an existing clinical workflow and infrastructure. The challenge lies in balancing the technical requirements of the new equipment with the operational realities of the healthcare facility, ensuring patient safety, regulatory compliance, and clinical efficacy. Careful judgment is required to navigate potential conflicts between vendor specifications, hospital policies, and established safety protocols. The correct approach represents best professional practice because it prioritizes a systematic, risk-based integration process. This involves thorough site assessment, validation of environmental conditions against manufacturer specifications, and a phased implementation plan that includes rigorous testing and training. This aligns with regulatory expectations for ensuring medical devices are installed and operated safely and effectively, minimizing risks to patients and staff. It also reflects ethical obligations to provide high-quality patient care through reliable equipment. An incorrect approach that bypasses thorough environmental validation and relies solely on vendor assurances fails to uphold the professional responsibility to independently verify critical installation parameters. This could lead to equipment malfunction, inaccurate diagnostic results, and potential patient harm, violating fundamental safety principles and potentially contravening regulatory requirements for device performance and safety. Another incorrect approach that prioritizes rapid deployment over comprehensive testing and staff training introduces significant risks. Inadequate training can lead to improper operation, misinterpretation of results, and potential equipment damage. This neglects the crucial aspect of human factors in device utilization and can result in adverse events, failing to meet the standard of care and regulatory mandates for competent use of medical technology. A third incorrect approach that neglects to establish clear communication channels and feedback mechanisms with clinical end users during implementation overlooks the importance of user acceptance and workflow integration. This can lead to suboptimal use of the equipment, resistance to adoption, and ultimately, a failure to realize the intended clinical benefits, which is a disservice to both patients and the healthcare institution. The professional reasoning process for such situations should involve a structured approach. First, thoroughly understanding the equipment's technical and safety requirements. Second, assessing the existing infrastructure and operational environment for compatibility. Third, developing a detailed implementation plan that includes risk mitigation strategies. Fourth, executing the plan with rigorous testing and validation. And finally, establishing ongoing monitoring and feedback loops to ensure continued safe and effective operation. This systematic process ensures that all stakeholders' needs are considered and that patient safety and regulatory compliance are paramount. Question 13. Investigation of a newly installed diagnostic imaging system reveals intermittent electrical interference affecting its display, accompanied by a faint buzzing sound from the power supply unit. The clinical staff reports no immediate patient harm, but expresses concern about the system's reliability. What is the most appropriate initial approach for the biomedical equipment technician to ensure safety and compliance? Option A. Conduct a comprehensive risk assessment, consulting relevant electrical safety and EMC standards, e.g., IEC 60601 series, to systematically identify potential hazards, evaluate their severity, and determine appropriate mitigation strategies before proceeding with any corrective actions. Option B. Immediately attempt to isolate and replace the power supply unit, assuming it is the source of the buzzing sound and interference. To restore system functionality as quickly as possible. Option C. Focus solely on troubleshooting the display interference, as this is the most visible symptom, and defer investigation of the power supply buzzing until the primary issue is resolved. Option D. Advise clinical staff to continue using the system with caution, monitoring for any escalation of the electrical interference or audible anomalies, and document the observations for future reference. The correct answer is A. Conduct a comprehensive risk assessment, consulting relevant electrical safety and EMC standards, e.g., IEC 60601 series, to systematically identify potential hazards, evaluate their severity, and determine appropriate mitigation strategies before proceeding with any corrective actions. Explanation. This scenario presents a common challenge for biomedical equipment technicians, BMET, involving a medical device exhibiting unusual electrical behavior. The core challenge lies in balancing the immediate need for device functionality with the paramount importance of patient and operator safety, particularly concerning electrical hazards and electromagnetic compatibility, EMC. A thorough risk assessment is crucial to systematically identify, evaluate, and control potential hazards before and during any intervention. The correct approach emphasizes a structured, evidence-based risk assessment process aligned with regulatory requirements for medical device safety. This involves understanding the device's intended use, its operating environment, and potential failure modes. By systematically analyzing the observed electrical anomalies, the technician can prioritize safety measures, consult relevant standards e.g. IEC 60601 series for electrical safety and EMC, and determine the appropriate course of action, which may include immediate device deactivation, further diagnostic testing, or consultation with the manufacturer. This approach ensures that all potential risks are considered and mitigated according to established safety protocols and regulatory mandates, representing best professional practice. Incorrect approaches fail to adequately address the inherent risks associated with electrical anomalies in medical equipment. One incorrect approach might involve immediately attempting to rectify the issue without a formal risk assessment. This bypasses critical safety checks and could exacerbate the problem or introduce new hazards, violating fundamental principles of electrical safety and potentially contravening regulations that mandate a systematic approach to device maintenance and repair. Another incorrect approach might be to ignore the anomaly if the device appears to be functioning otherwise. This is a severe ethical and regulatory failure, as even minor electrical deviations can indicate underlying issues that pose significant risks to patients and operators, and it neglects the proactive safety responsibilities of a BMET. A third incorrect approach could be to rely solely on anecdotal experience without consulting official documentation or standards. While experience is valuable, it must be grounded in regulatory compliance and established safety guidelines to ensure comprehensive risk mitigation. Professional reasoning in such situations requires a systematic decision-making process. This begins with recognizing the potential for harm. The technician must then gather information about the device and the observed anomaly, consult relevant technical documentation and safety standards, and perform a risk assessment to identify hazards and evaluate their severity and likelihood. Based on this assessment, appropriate control measures are implemented, prioritizing patient and operator safety. This iterative process ensures that all actions taken are informed, compliant, and aimed at maintaining the safe and effective operation of medical equipment. Question 14. What factors determine the appropriate safety protocols and operational readiness checks for nuclear medicine equipment following a reported malfunction, considering the potential for residual radioactive contamination and the need for immediate diagnostic imaging? Option A. The manufacturer's recommended maintenance schedule and the general guidelines for medical equipment functionality. Option B. The availability of replacement parts and the cost-effectiveness of immediate repairs versus temporary equipment rental. Option C. The urgency of the patient's diagnostic needs and the technician's personal experience with similar equipment malfunctions. Option D. The specific type of radiopharmaceutical used, the duration of the malfunction, and the established radiation safety protocols outlined by the Nuclear Regulatory Commission, NRC, and the facility's Radiation Safety Officer, RSO. The correct answer is D. The specific type of radiopharmaceutical used, the duration of the malfunction, and the established radiation safety protocols outlined by the Nuclear Regulatory Commission, NRC, and the facility's Radiation Safety Officer, RSO. Explanation. This scenario is professionally challenging because it requires a biomedical equipment technician, BMET, to balance the immediate need for a critical diagnostic tool with stringent safety protocols, particularly when dealing with radioactive materials. The potential for radiation exposure to patients, staff, and the technician themselves necessitates a cautious and informed approach. Misjudgments can lead to regulatory violations, compromised patient care, and significant safety risks. The correct approach emphasizes a thorough understanding and adherence to the established safety protocols for nuclear medicine equipment, including proper shielding, ventilation, and waste disposal, as mandated by relevant U.S. regulatory bodies such as the Nuclear Regulatory Commission, NRC, and the Food and Drug Administration, FDA. This approach prioritizes patient and personnel safety by ensuring all diagnostic procedures are conducted within safe radiation limits and that the equipment functions as intended to minimize unnecessary exposure. It also involves proper documentation and communication with the Radiation Safety Officer, RSO, which are critical for regulatory compliance and maintaining a safe environment. An incorrect approach that bypasses or inadequately addresses safety protocols, such as attempting to operate the equipment without verifying its radiation containment or proper ventilation, represents a severe regulatory and ethical failure. It directly violates NRC and FDA guidelines designed to prevent radiation overexposure. Another incorrect approach, focusing solely on restoring functionality without considering the implications of potential residual radiation or the need for specialized decontamination procedures, also fails to meet professional standards and regulatory requirements. This could lead to the spread of contamination and pose long-term health risks. Furthermore, an approach that neglects to involve or inform the RSO about the equipment's status and the planned maintenance or repair activities is a critical ethical and regulatory lapse, as the RSO is responsible for overseeing radiation safety compliance. Professional decision-making in such situations requires a systematic process. First, identify the critical nature of the equipment and the immediate need. Second, consult all relevant safety manual, regulatory guidelines, e.g., NRC, FDA, state-specific regulations, and institutional policies. Third, assess the specific risks associated with the equipment's malfunction, particularly concerning radiation safety. Fourth, prioritize safety and regulatory compliance over speed. Fifth, communicate effectively with the RSO and other relevant personnel. Finally, document all actions taken and decisions made. Question 15. When evaluating the potential risks associated with a failing oxygen saturation sensor on a non-invasive patient monitor used in a general ward setting, which approach best aligns with regulatory expectations for biomedical equipment technicians? Option A. Rely on the fact that the monitor has a history of reliable performance, suggesting that a single sensor issue is unlikely to pose a significant threat. Option B. Focus on the sensor's warranty status and the cost of replacement, assuming that if it's under warranty, the risk is managed by the manufacturer. Option C. Prioritize assessing the sensor's impact on patient oxygenation, the potential for delayed detection of critical changes, and the availability of alternative monitoring methods or alarms. Option D. Investigate the technical specifications of the sensor to determine its accuracy range, without considering the specific clinical scenario or patient population. The correct answer is C. Prioritize assessing the sensor's impact on patient oxygenation, the potential for delayed detection of critical changes, and the availability of alternative monitoring methods or alarms. Explanation. This scenario presents a professional challenge because the biomedical equipment technician, BMET, is tasked with assessing the risk associated with a sensor failure in a critical care device without direct access to the manufacturer's detailed risk analysis documentation. This requires the BMET to apply their understanding of sensor technology, device function, and potential patient impact to infer risks. The challenge lies in balancing the need for thoroughness with practical limitations. Ensuring patient safety remains paramount while adhering to regulatory expectations for equipment management. The correct approach represents best professional practice because it systematically addresses the potential consequences of sensor failure by considering the device's intended use, the criticality of the monitored parameter, and the potential for compensatory mechanisms. This aligns with regulatory frameworks that mandate proactive risk management and the implementation of appropriate controls to ensure the safety and effectiveness of medical devices. By prioritizing patient safety and considering the hierarchy of controls, the BMET demonstrates a commitment to ethical practice and regulatory compliance. An incorrect approach that focuses solely on the sensor's technical specifications without considering its clinical application fails to adequately assess risk. This is a regulatory failure because it neglects the fundamental principle that medical device risk is determined by the interaction of the device with the patient and the clinical environment. Another incorrect approach that relies on anecdotal evidence or assumptions about device reliability, without objective data or manufacturer guidance, is ethically problematic as it introduces an unacceptable level of uncertainty into patient care decisions. This also represents a regulatory failure by not adhering to established protocols for equipment assessment and maintenance. Professionals should employ a decision-making framework that begins with understanding the device's intended use and the clinical context. This is followed by identifying potential failure modes of critical components like sensors, assessing the severity of the potential harm resulting from each failure, and evaluating the likelihood of such failures occurring. Based on this risk assessment, appropriate mitigation strategies, such as enhanced monitoring, preventive maintenance, or device replacement, should be implemented. This systematic approach ensures that decisions are evidence-based, patient-centered, and compliant with regulatory requirements. Question 16. Quality control measures reveal that an anesthesia machine in active use in the operating room is intermittently displaying an error code related to its oxygen sensor calibration, despite recent routine maintenance. The surgical team is in the middle of a complex procedure, and the machine is currently functioning within acceptable parameters according to the display. What is the most appropriate immediate course of action for the biomedical equipment technician? Option A. Continue to monitor the anesthesia machine closely during the remainder of the procedure, as it is currently functioning within acceptable parameters, and schedule a full diagnostic evaluation for after the case concludes. Option B. Attempt a quick field recalibration of the oxygen sensor using the machine's built-in diagnostic tools to clear the error code and allow the procedure to continue uninterrupted. Option C. Inform the anesthesiologist of the intermittent error code, but allow them to make the final decision on whether to continue using the machine for the duration of the current procedure. Option D. Immediately remove the anesthesia machine from service, document the observed intermittent error code and the circumstances, and initiate a full diagnostic evaluation and recalibration by qualified personnel. The correct answer is D. Immediately remove the anesthesia machine from service, document the observed intermittent error code and the circumstances, and initiate a full diagnostic evaluation and recalibration by qualified personnel. Explanation. This scenario presents a common challenge in a critical care environment where equipment failure can have immediate and severe patient consequences. The professional challenge lies in balancing the urgency of patient care with the imperative of ensuring equipment safety and compliance. A hasty or incomplete response can lead to patient harm, regulatory violations, and damage to the healthcare facility's reputation. Careful judgment is required to prioritize actions, communicate effectively, and adhere to established protocols. The correct approach represents best professional practice because it prioritizes patient safety and regulatory compliance through a systematic and documented process. Immediately removing the anesthesia machine from service, documenting the issue, and initiating a thorough investigation aligns with the principles of patient safety and risk management mandated by regulatory bodies governing biomedical equipment. This approach ensures that a potentially faulty device is not used on a patient and that the root cause of the malfunction is identified and addressed, preventing recurrence. It also fulfills the ethical obligation to provide safe and effective care. An incorrect approach that involves attempting a quick field repair without proper documentation or verification of the fix is professionally unacceptable. This bypasses established safety protocols and regulatory requirements for equipment maintenance and validation. It poses a significant risk of patient harm if the repair is inadequate or introduces new issues. Ethically, it violates the duty of care to the patient and the principle of non-maleficence. Regulatory failure would stem from not following approved maintenance procedures and potentially using equipment that has not been properly cleared for use. Another incorrect approach, such as continuing to use the anesthesia machine while awaiting a more convenient time for repair, is a severe ethical and regulatory breach. It directly jeopardizes patient safety by knowingly exposing them to a malfunctioning device. It demonstrates a disregard for established safety standards and regulatory mandates that require equipment to be in safe working order before use. This action would likely result in serious consequences, including patient harm, regulatory sanctions, and legal liability. A professional decision-making process for similar situations should involve a clear, step-by-step protocol. First, immediately assess the immediate risk to patient safety. If the equipment is critical for ongoing patient care, ensure a safe transition to an alternative device or procedure. Second, remove the suspect equipment from service and clearly label it as out of service or do not use. Third, thoroughly document the observed malfunction, including any error codes, patient impact, and the circumstances surrounding the failure. Fourth, initiate the appropriate repair and recalibration process according to the manufacturer's guidelines and facility protocols. Fifth, perform comprehensive testing and validation after repair to ensure the equipment is functioning within specifications and is safe for patient use. Finally, communicate the issue and resolution to relevant stakeholders, including clinical staff and management, and update maintenance records. This systematic approach ensures patient safety, regulatory compliance, and continuous improvement in equipment management. Question 17. Cost-benefit analysis shows that a new generation of electrosurgical units and endoscopes offers enhanced imaging resolution and advanced therapeutic capabilities, but at a significantly higher initial purchase price compared to current models. Which of the following approaches best represents a responsible and compliant decision-making process for a biomedical equipment technician in this scenario? Option A. Prioritize the acquisition of the new equipment based on its advanced features and potential for improved patient outcomes, assuming that higher cost directly correlates with superior performance and safety, and deferring detailed validation until after implementation. Option B. Focus solely on the advanced technological features and potential for research applications, without a detailed evaluation of the equipment's integration into existing clinical workflows or its long-term maintenance requirements, as the cutting-edge nature of the technology is the most critical factor. Option C. Select the least expensive option available that meets the basic functional requirements, as cost savings are the primary objective, and assume that all equipment from reputable manufacturers will perform adequately and safely. Option D. Conduct a thorough total cost of ownership analysis, including maintenance, training, service contracts, and potential downtime, alongside a comprehensive risk assessment and validation of regulatory compliance and performance against established clinical needs and safety standards. The correct answer is A. Prioritize the acquisition of the new equipment based on its advanced features and potential for improved patient outcomes, assuming that higher cost directly correlates with superior performance and safety, and deferring detailed validation until after implementation. Explanation. This scenario presents a common challenge for biomedical equipment technicians, BMET, involving the selection and implementation of new medical technology, specifically electrosurgical units, ESU, and endoscopes. The professional challenge lies in balancing the perceived benefits of advanced features against the practical realities of integration, training, maintenance, and regulatory compliance within a healthcare setting. Careful judgment is required to ensure that the chosen equipment not only meets clinical needs, but also adheres to safety standards, operational efficiency, and budgetary constraints, all while prioritizing patient safety and effective healthcare delivery. The correct approach emphasizes a comprehensive evaluation that extends beyond initial cost to encompass the total lifecycle cost and operational impact. This includes thorough risk assessment, validation of performance against established standards, and ensuring adequate training and support. This aligns with best professional practice by prioritizing patient safety and equipment efficacy, as mandated by regulatory bodies like the FDA in the U.S. context, assuming this is the specified jurisdiction for BMET certifications. Adherence to manufacturer guidelines, established service protocols, and relevant safety standards, e.g., IEC 60601 series for medical electrical equipment, are paramount. This approach ensures that the chosen technology is not only functional but also safe, reliable, and sustainable within the healthcare environment. An incorrect approach that focuses solely on the lowest acquisition cost fails to consider the long-term implications. This can lead to higher maintenance costs, increased downtime, and potential safety hazards if the equipment is not robust or if adequate support is not available. Ethically, this approach compromises patient safety and the quality of care. Another incorrect approach that prioritizes advanced features without a clear clinical need or adequate training can result in underutilization, increased complexity in troubleshooting, and potential for user error, thereby increasing risk. This also represents a failure to adhere to best practices in technology adoption and risk management. A third incorrect approach that neglects to verify regulatory compliance and safety certifications, e.g., FDA clearance, is a direct violation of legal and ethical obligations, potentially exposing the facility to significant liability and, more importantly, endangering patients. The professional decision-making process for similar situations should involve a multidisciplinary team, including clinical staff, IT, procurement, and BMET. A structured evaluation process should be implemented, encompassing needs assessment, technical evaluation, risk assessment, total cost of ownership analysis, and verification of regulatory compliance. Prioritizing patient safety, clinical efficacy, and long-term operational viability should guide all decisions. Question 18. Strategic planning requires a biomedical equipment technician to respond to a critical sterilizer malfunction during a peak surgical demand period. The sterilizer has failed to complete its cycle, and the immediate need for sterile instruments is high. What is the most appropriate course of action to ensure patient safety and regulatory compliance? Option A. Immediately remove the sterilizer from service, initiate a full diagnostic and repair process, and perform a complete validation cycle before it is used again. Option B. Attempt basic troubleshooting, and if the cycle appears to complete, resume immediate use to meet clinical demand. Option C. Utilize an alternative sterilization method without formal validation as a temporary measure to address the immediate need. Option D. Rely solely on the manufacturer's basic troubleshooting guide and resume operation once the error code is cleared. The correct answer is A. Immediately remove the sterilizer from service, initiate a full diagnostic and repair process, and perform a complete validation cycle before it is used again. Explanation. Scenario analysis. This scenario presents a common challenge in healthcare settings where a critical piece of equipment, a sterilizer, fails during a period of high demand. The challenge lies in balancing the immediate need for sterile instruments to maintain patient care, with the imperative to adhere to strict regulatory requirements for sterilization validation and equipment maintenance. The technician must make a rapid, informed decision that prioritizes patient safety, while also ensuring compliance with established protocols and manufacturer guidelines. The pressure of a busy surgical schedule adds a layer of urgency, potentially tempting shortcuts. Correct approach analysis. The correct approach prioritizes patient safety and regulatory compliance by immediately removing the affected sterilizer from service and initiating a thorough investigation and validation process. This aligns with the fundamental principles of biomedical equipment management, which emphasize preventing the use of non-compliant or potentially compromised equipment. Regulatory bodies, such as those governing medical device reprocessing, e.g., FDA in the US, MHRA in the UK, mandate that sterilization processes must be validated and that any equipment malfunction requires immediate corrective action and revalidation before it can be used again. This ensures that all instruments processed are sterile and safe for patient use, thereby preventing healthcare-associated infections. Ethically, the technician has a duty of care to patients, which is upheld by this rigorous approach. Incorrect approaches analysis. One incorrect approach involves attempting to troubleshoot and immediately resume operation without proper validation. This poses a significant regulatory failure, as it bypasses the requirement for documented proof that the sterilization cycle achieved the necessary parameters to kill microorganisms. It also represents an ethical failure, as it knowingly risks patient safety by using potentially non-sterile instruments. Another incorrect approach is to rely solely on the manufacturer's basic troubleshooting without engaging in a full validation cycle. While manufacturer guidance is important, it does not replace the facility's responsibility to ensure the sterilizer is functioning correctly within its specific operational environment, and that the sterilization process is validated for the types of loads being processed. Failure to perform a full validation after a malfunction is a breach of regulatory requirements and an ethical lapse in patient care. A third incorrect approach might be to use an alternative sterilization method without first confirming its suitability and validation for the specific instruments and the current clinical demand. While alternative methods exist, their efficacy must be established and documented, and their use should be part of a pre-approved protocol. Improvising sterilization methods in response to equipment failure without proper validation is a serious regulatory and ethical violation. Professional reasoning. Professionals in this situation should employ a systematic decision-making process. First, they must recognize the critical nature of sterilization and the potential patient harm from non-sterile instruments. Second, they should consult relevant regulatory guidelines and manufacturer's service manuals for the specific sterilizer model. Third, they must immediately isolate the faulty equipment and document the issue. Fourth, they should initiate the prescribed corrective action, which typically involves repair and a full validation cycle. Fifth, they should communicate effectively with clinical staff regarding the equipment status and any impact on surgical schedules, exploring approved alternative solutions if necessary. This process ensures that patient safety remains paramount while adhering to all professional and regulatory obligations. Question 19. The monitoring system demonstrates intermittent, low-amplitude voltage fluctuations on its DC power supply rail that do not immediately trigger an alarm, but are outside the manufacturer's specified tolerance for stable operation. Option A. Immediately recalibrate the DC power supply to bring the voltage within the specified tolerance, assuming the fluctuations are a minor drift. Option B. Document the fluctuation. Consult the device's service manual for troubleshooting steps related to DC power integrity, and perform diagnostic tests to identify the source of the instability before considering any adjustments. Option C. Ignore the fluctuations as they are not triggering an alarm and do not appear to be significantly impacting immediate patient readings. Option D. Adjust the gain settings on the monitoring channels to compensate for the perceived instability in the DC power. The correct answer is B. Document the fluctuations. Consult the device's service manual for troubleshooting steps related to DC power integrity, and perform diagnostic tests to identify the source of the instability before considering any adjustments. Explanation. This scenario presents a professional challenge because it involves a critical medical device exhibiting an anomaly that could impact patient care. The technician must balance the immediate need for accurate patient monitoring with the imperative to maintain device integrity and adhere to established protocols. The core of the challenge lies in interpreting the observed behavior within the context of AC and DC circuit principles, understanding potential causes, and selecting an appropriate course of action that prioritizes patient safety and regulatory compliance. The correct approach involves a systematic, evidence-based troubleshooting process that aligns with regulatory requirements for medical device maintenance and patient safety. This approach prioritizes patient well-being by ensuring the monitoring system is functioning as intended or is immediately addressed if it is not. It also upholds professional ethics by demanding thorough investigation before making assumptions or implementing potentially disruptive solutions. Adherence to manufacturer guidelines and internal hospital policies, which are often informed by regulatory frameworks like those governing biomedical equipment in the U.S. e.g. FDA regulations concerning medical device maintenance and reporting, is paramount. This ensures that all actions are documented, traceable, and contribute to the overall safety and efficacy of medical equipment. An incorrect approach would be to ignore the anomaly, assuming it is a minor fluctuation or a known, benign characteristic of the system without proper verification. This failure directly contravenes the ethical obligation to ensure patient safety and the regulatory requirement to maintain medical devices in a safe and functional state. Another incorrect approach would be to immediately recalibrate the system without first investigating the root cause of the observed behavior. This could mask a more serious underlying circuit issue, potentially leading to inaccurate readings and misdiagnosis, thereby violating patient safety standards and potentially FDA reporting requirements for device malfunctions. Furthermore, making assumptions about the nature of the AC/DC circuit behavior without consulting schematics or diagnostic tools would be unprofessional and could lead to incorrect repairs, further compromising device performance and patient safety. Professionals should approach such situations by first observing and documenting the anomaly precisely. Next, they should consult the device's technical manual and relevant schematics to understand the expected AC and DC circuit operation. This is followed by systematic diagnostic testing, using appropriate test equipment to isolate the source of the deviation. If the anomaly persists or its cause is unclear, escalation to a supervisor or manufacturer support is the next logical step, ensuring that patient care is not compromised and that all actions are compliant with regulatory and ethical standards. Question 20. System analysis indicates a critical patient monitoring device is scheduled for its annual preventive maintenance, PM, as per manufacturer guidelines. However, the clinical department urgently requires the device for continuous patient care and states that no alternative device is readily available. The biomedical equipment technician, BMET, is aware that delaying the PM could potentially increase the risk of device malfunction, but also understands the immediate need for the device in patient care. What is the most appropriate course of action for the BMET? Option A. Perform the preventive maintenance only when the device is not in use, without regard for the manufacturer's recommended interval, believing that usage is the primary factor in maintenance needs. Option B. Perform a shortened, quick check maintenance procedure on the device to ensure it is functional for immediate patient use, rather than the full manufacturer-recommended preventive maintenance. Option C. Adhere to the manufacturer's recommended preventive maintenance schedule, communicate the importance of the PM to the clinical department, and work collaboratively to find a temporary solution for device availability, such as rescheduling the PM for a brief period during off-peak hours or exploring loaner options. Option D. Defer the preventive maintenance indefinitely until the clinical department deems the device no longer critical, prioritizing immediate patient care needs over scheduled maintenance. The correct answer is C. Adhere to the manufacturer's recommended preventive maintenance schedule, communicate the importance of the PM to the clinical department, and work collaboratively to find a temporary solution for device availability, such as rescheduling the PM for a brief period during off-peak hours or exploring loaner options. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in healthcare technology management. A biomedical equipment technician, BMET, is faced with conflicting priorities, adhering strictly to a manufacturer-recommended preventive maintenance, PM, schedule versus the immediate operational needs of a critical medical device. The challenge lies in balancing patient safety and device reliability with the demands of clinical departments and the potential for disruption. The BMET must exercise sound professional judgment, considering the regulatory framework, manufacturer guidelines, and the potential impact of their decision on patient care. Correct approach analysis. The correct approach prioritizes patient safety and regulatory compliance by adhering to the established PM schedule. This aligns with the fundamental principles of biomedical equipment management, which emphasize proactive maintenance to prevent failures. Regulatory bodies, such as those governing medical device oversight in the U.S., e.g., FDA, mandate that healthcare facilities maintain medical equipment in safe and effective working order. Manufacturer recommendations for PM are based on extensive testing and are designed to ensure optimal performance and longevity, thereby minimizing the risk of device malfunction during patient use. Deviating from these protocols without a documented, risk-assessed justification can lead to regulatory noncompliance and increased liability for the healthcare facility. Incorrect approaches analysis. One incorrect approach involves deferring the PM indefinitely until a more convenient time. This is a significant regulatory and ethical failure. It directly contravenes the principles of proactive maintenance and increases the risk of device failure, potentially compromising patient safety. Such a decision could be viewed as negligence and would likely violate facility policies and regulatory requirements for equipment maintenance. Another incorrect approach is to perform the PM only when the device is not in use, without considering the manufacturer's recommended interval. While seemingly practical, this approach ignores the critical aspect of the PM schedule's timing. PMs are often time-based to address wear and tear, calibration drift, or software updates that occur over a specific period, regardless of device usage. Delaying a scheduled PM, even if the device has been in use, can lead to missed critical maintenance tasks, increasing the likelihood of failure before the next scheduled interval. This also represents a deviation from manufacturer guidelines and regulatory expectations for maintaining equipment in a safe and effective state. A third incorrect approach is to perform a quick check instead of the full PM, believing it is sufficient. This is a dangerous shortcut that bypasses essential diagnostic and calibration procedures outlined in the manufacturer's PM protocol. Such an abbreviated maintenance process does not guarantee the device's continued safe and effective operation and can lead to undetected issues. This approach fails to meet the standards of care expected for medical equipment maintenance and exposes both the patient and the facility to unacceptable risks. Professional reasoning. Professionals in this field should employ a risk-based decision-making framework. This involves understanding the criticality of the device, the potential consequences of device failure, and the specific requirements of the manufacturer's PM protocol. When faced with conflicting demands, the BMET should first consult the established PM schedule and manufacturer guidelines. If an immediate need for the device conflicts with the scheduled PM, the BMET should communicate the importance of the PM to clinical staff and explore options for rescheduling the PM with minimal disruption, such as performing it during off-peak hours or arranging for a loaner device. If a deviation is absolutely unavoidable and a documented risk assessment indicates a low immediate risk, it must be formally documented, approved by appropriate management, and a plan for immediate completion of the PM must be established. The ultimate responsibility lies in ensuring patient safety and regulatory compliance.